Hey guys, today we are going to start our second lesson over factoring polynomials when a is greater than 1. So that means the number in front of x squared is going to be something other than 1. So everyone needs to make sure that they have the paper from the back, and you're also going to need to have a calculator on your desk today as well. We have already talked about slide and divide. If you remember my super cool dance moves with slide and divide, slide and divide. Yeah, I'm sure y'all all probably just pictured me doing that ridiculous dance in your head. Maybe it made you laugh. Maybe it made you roll your eyes. Either way, I'm still hoping that it catches on for a TikTok trend. But whether or not people start dancing to the slide and divide or not, we are going to still use it to factor our polynomials when there's a number in front of x squared. What we're also going to focus on today is checking it with our calculators. Okay, I only put 10 questions on your paper today. We're going to do 4 of them together. So that means you will have plenty of time to get the practice in on double checking on how to grab them and check them in your calculators. All right, so let's go ahead and get started. If you notice on your notes section for today, I left it filled in for you. So we're just going to talk about it really quick. When we need to factor a polynomial, if there is a number in front of x squared, our factoring rules will not work. We will use those factoring rules, but we also have to do something else first. First and foremost, we want to check to make sure that there's not a greatest common factor that we can take out. On today's assignment, we do not have any GCFs. But remember, that is the first rule of factoring polynomials, is to check and see if there's something that you can divide out of each term. If a is something other than 1 and there is no GCF, that's when we use slide and divide, slide and divide. What does slide and divide mean? Slide and divide means that we are going to take the number in the front of our polynomial, the value for a, and slide it to the back. Remember, when we slide things or pass things out in math, we use multiplication. So we are going to multiply the coefficient, the big number in front of a, onto c, the constant number at the back. So we're just going to take the big number in front and multiply it onto our term in the back. Then we can use our factoring rules. We're going to factor just like normal. We should have something that looks like this, where x squared is by itself in the front, and our new number in the back that we just multiplied together, that's what we're going to factor first. So we're going to make a factor T chart for whatever number we get when we multiply a times c. After we make our factor T chart, we're looking for the factor pair that does this to get this. So we'll look here at the sign in front of c and either add or subtract to get the number here for b. Once you have that set up, you're going to split up your x's and you're going to split up your factor pair. And the only thing you have left is to figure out if your signs are supposed to be pluses, minuses, or a plus and minus. And to do that, we're going to look at the sign of c first. If it's a plus c, that means your signs are the same. So they're either both going to be pluses or they're both going to be minuses. If it's a minus c, that means your signs are different. So one will be a plus and one will be a minus. To tell what they're supposed to be, we look at the sign of b. B is the boss. It will tell us what signs to use. Remember, if signs are different, the bigger number is the boss. So after we do our factoring, since we did a slide, we have to remember to divide. Remember, math is fair. If I do something on one side, I have to do it to the other. Well, since there's not 2 sides of a polynomial, if we do something to change our original problem, we have to make sure that we go back and undo it. So since we multiplied that problem on at the end, now we need to undo that multiplication by dividing. I told y'all on Monday of this week that a lot of times I like to write the S with the line and the D on my problem so I don't forget to divide at the end. The dividing step is very important, or else your answer will be wrong. So what we want to do is we want to divide the number that we multiplied out of each term. When we do that, we're going to get fractions, and we want to simplify those fractions. If the fraction simplifies to a whole number, we're just going to leave it. If it simplifies to another fraction or even the same fraction, we're just going to take that denominator and push it to the front because we don't keep fractions in our answers. So let's take a look at that. Let's take a look at number 1. I notice that there's a number in front of x squared. I cannot divide it out because I cannot divide 11 by 2 or 5 by 2 evenly, and I have to be able to divide all the pieces out for it to be a GCF. So like I said, we don't really have to worry about GCFs today. None of these problems have a GCF, but you do always want to check that first. And if you can't factor out a GCF, that's when it's time to slide and divide. So we're going to slide that 2 to the back of the problem. Remember, I like to write the slide and divide, or the S and the D, down the side of my paper so I don't forget to divide later on. When I slide the 2 back to that 5, I know that I'm going to use multiplication. The rest of the problem is going to come down, so my new problem becomes x squared plus 11x plus 10. That 10 came because we did 2 times 5 there at the end. Okay. Now, since there's not a number in front of my x squared, I can factor using those steps that we normally use. So we're going to start by factoring out our last term of 10. When I make my t-chart, I always want to start with the number 1, 1 and 10. Then I keep counting up till I meet myself. 2 and 5, because 10 divided by 2 is 5, or you could say 2 times 5 is 10, whichever way it makes more sense to you. 3, there's nothing that I can multiply times 3. 10 divided by 3 gives me a fraction. 10 divided by 4 gives me a fraction. 10 divided by 5, well, since 5 is already on my chart, I know that I'm done. So once I have my t-chart finished, I'm trying to find the factor pair that does this to get this. So we want them to do this, add, to get us 11. Well, 1 plus 10 is equal to 11. So that's the factor pair that I want to use. I'm going to split up my x's, and I'm going to split up my 1 and my 10. Now, when we're looking for signs, we have to look at the sign of C first. Since it's a plus 10 at the end, that means signs are going to be the same. The boss sign of B is a plus, so that means they're both going to be pluses. I am not finished yet. Since I did a slide, I have to divide. Since I multiplied a 2 on, I'm going to divide a 2 out from each of those terms. In my calculator, I go to simplify those fractions. When I do 1 divided by 2, it simplifies to the fraction 1 over 2. Since I can't leave fractions in my answer, I take the denominator and I just push it to the front of that term. It becomes 2x plus 1. For my second factor, I'm going to divide 10 divided by 2. 10 divided by 2 is 5. So since it's a whole number, we're just going to simplify it to a whole number and let it stay x plus 5. So my final answer is 2x plus 1 times x plus 5. Once again, it's very important that we graph this to check our work today. There's multiple ways that you can graph these to check your work. We're going to go in and graph our original problem. Type it in exactly how it looks, the 2x squared plus 11x plus 5. You notice you're going to get that U-shaped parabola. Tab button allows you to graph another graph right on top of it. When you graph your answer choice, you'll notice that that blue graph turns to a different color because you have just graphed the same graph right on top of each other. Another option that we have is to graph the individual factors. So if I were to graph the 2x plus 1 on the same graph as my question, it's going to give me a straight line. But notice that it shares a common 0. It crosses the graph at the x-axis in the same spot my problem does. It is very important for you to remember that factors share zeros with your problem. So to double check that each of those factors are correct, you know that it should cross the x-axis at the same spot as your graph did. That's where those graphs are going to intersect. For today, it's perfectly fine if you just do the first one where you're only graphing the question and the final answer to make sure that they overlap and are the same exact graph, because if they're the same exact graph, that means they are equal to each other. Same and equal mean the same thing, okay? But either way, I want to make sure that we're using that graph to double check our work. Let's skip on down to the one that looks like this, x squared plus 2x plus 4. If you notice, this is not a slide and divide problem. It's just a regular factoring problem. But you're going to notice it's a little different than the ones that we've done before. Since there's not a number in front of x squared, I can just start by factoring out my last term of 4. To factor out 4, I'm going to start with 1, 1 and 4, 2 and 2. Since those numbers are the same, I know that I'm done. And now I'm looking for the factor pair that add together to give me 2. Well, 1 plus 4 is 5, and 2 plus 2 is 4. So there's not a factor pair that add up to equal 2. So in a case like this, we say that this is not factorable, or there are no real factors. To double check yourself on your graph, you would go in and graph your question. X squared plus 2x plus 4. And you notice that that graph is never going to reach the x-axis. If your graph does not cross the x-axis, it does not have a 0. And remember, factors have the same 0, the same x-intercept as your graph does. So if your graph doesn't touch the x-axis, then there are no factors for that graph. So this is a good way to double check before you say that it's not factorable. If it's not factorable, when you graph it, it should not touch or cross the x-axis. Let's move down to the next problem. X squared minus 64. We did some problems like this earlier this week. We noticed that this was really missing a piece. It was missing that inside piece. Well, that means I don't have any x's. I have 0 of them. So you can rewrite it in an expanded form, just putting a plus 0x. Then you'll continue to factor it out the same way. We're going to make a t-chart for 64. 1 and 64. 64 divided by 2 is 32. 64 divided by 3 is a fraction. 64 divided by 4 is 16. 64 divided by 5 is a fraction. Divided by 6 is a fraction. Divided by 7 is a fraction. 64 divided by 8 is 8. And since those are the same numbers, I've met myself and I can stop. Now, I want these numbers to subtract to equal 0 because we want them to go away. So that means it has to be the same number. So we're going to split up our x's and we're going to split up our 8's. Since it's a minus 64 at the end, that means our signs are different. So one has to be a plus and one has to be a minus. And it doesn't matter which one you write first. This is called the difference of two perfect squares. If you have a perfect square at the beginning, x squared can be split up into x and x. And 64 can be split up into 8 times 8 if you're multiplying the same number together. As long as you are subtracting those two things, that's why it's called the difference of two perfect squares. All you have to do is split them up, and one's a plus and one's a minus. Let's take a look here at your calculator. Just double check that work. We're going to go in and we're going to graph our question. When I push the tab button to graph another one right on top, I'm going to do the x plus 8 and the x minus 8, making sure they're both in parentheses. And I noticed that that graph changed colors because we graphed that new graph right on top. If I were to graph each individual term, you notice that they're going to share a 0. They're going to share an x-intercept with the graph. One at +8 and one at -8. Once again, that is a special factoring term called the difference of squares. That is located on your green sheet on your star reference chart. It says if the first term is a perfect square and you're subtracting something else that's a perfect square, you can split up the A's and split up the B's and make one a plus and one a minus. If you like that shortcut and you can recognize it easily, you're more than welcome to use it. But a lot of people don't notice it right off the bat, and that's okay because you can still factor them out the same way we factored all the other ones. You just have to remember to add in that +0x in the middle. Last example that we're going to do together today. Once again, I have a number in front of x squared. And since I can't factor that 9 out of each piece, we are going to use our slide and divide. We're going to slide that 9 to the back so the x squared comes down, the -12x comes down, and plus 9 times 4 is 36. So our new equation is x squared minus 12x plus 36. Now we can continue to use the same rules that we use for factoring and make our t-chart for 36. Starting with the number 1 and 36. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 5 gives us a fraction, and 36 divided by 6 is 6. I want these numbers to add up to equal 12. So we're going to be using our 6 and 6 here. We're going to split up our x's and we're going to split up our 6 and 6. Since C is a plus, since it's a plus 36, I know that my signs should be the same. Looking at the boss sign, since the boss is a minus, it means both of those signs are going to be minuses. We're not done yet though, because since we did a slide, we have to divide. We're going to divide each of those terms by 9. When I divide 6 divided by 9 in my calculator, I get 2/3. So my term becomes x minus 2/3, x minus 2/3. If you notice, that's the same factor written out twice. Okay. Also notice that there's fractions there, and we can't leave fractions in our answer. So we're going to take this 3 and we're going to push it to the front, making it 3x minus 2. We do that to both terms. So my final answer should be 3x minus 2 times 3x minus 2. But once again, since that's the same exact term, you're going to see that written as 3x minus 2 squared. You can always graph that in your calculator. So we're going to go back here to our calculator and check our work. When I graph my original problem, I'm looking for the parabola. If you notice, the parabola touches the x-axis in one spot. That's because our factor ended up being the same number. That means it's only going to cross it in that one spot. You can double check yourself by graphing your answer choices, and you notice that the graphs lie right on top of each other because they're the same. If you didn't graph the squared and just graphed one of those individual terms, once again, they're still going to cross right here on the same 0, the same x-intercept. That is an example of a perfect square trinomial. This one's a little bit harder to see, and it's a little bit extra steps. So once again, that slide and divide, you can just use that every time. It's still going to give you the correct answer. But what this is saying is if you have a perfect square in the front and a perfect square at the end, and the middle is double that, then you have a perfect square trinomial. Please do not forget that report card grades go in on Friday, tomorrow. Make sure that if you are updating any of your work for my class, that you're sending me an email about it so I know to double check your work. Continue to work on this paper. You're welcome to work with your table. Make sure that you're using your calculator to check your work.